Physics 1, and here is Giancoli Chapter 6, number 19. I really like this problem because it makes you go through those two definitions of work. The first definition being W is force times distance, and the other one being, the work energy principle. So let's hop into it. An 88-gram arrow is fired from a bow whose string exerts an average force of 110 newtons on the arrow over a distance of 78 centimeters. What is the average speed? What is the speed of the arrow as it leaves the bow? So here we have a bow, right? This is a bow. Draw this little arrow. Arrowed. And this thing weighs 88 grams. We should probably convert that to kilograms right now, right? So 88 divided by 1,000. So that's or 0.088 kilograms. And we know that the usual force is equal to 110 newtons, and the distance for that is usually 78 centimeters, like not even a meter. Not the best arrow, I gotta say. If your arrow can't even, but that's besides the point. So now we just gotta think about the system as a whole. Number one, I think this system is trying to imply that all of the work is conserved, right? It's a little string, so there's no place for the friction to really lose a lot of the energy. So we're going to assume that the energy is conserved here. And we're going to use the first equation for work as F times D. And the other equation for work is equal to 1/2 mv squared, right? And it looks like this work is the same, right? So we're just going to do F times D is equal to 1/2 mv squared. See that? Classic work, and then classic work versus the work energy theorem, and now we have this all tied together. So now we just have to solve for V. So that means 2FD is equal to mv squared. V is equal to 2FD divided by m, maybe squared, then square root. So our velocity is going to be the square root of 2FD divided by m. And then we just have to plug that sucker in. V is equal to the square root of 2 times 110 times, 78. I can't put 78. I got to put 0.78. I got to convert this to meters. This is 0.78 meters. 0.78 divided by the mass, which we know is 0.088. Good. So our velocity is like 44.3 meters per second. Cool. Big things that you need to notice in this sample is number one, we're using both definitions of work, which is why I'm doing a video, because it's kind of cool. We have to use both the definitions, all right? F times D and 1/2 mv squared, and there's also an assumption that all of the energy is conserved, right? We're not losing any energy through the air friction of the arrow, right? We're just assuming that that's not happening. Good. Hey, thank you very much for watching. Thank you for working so hard. I gotta tell you, you guys make my day, and you are very special to me. Keep working hard.